Hi, seventh grade. How are you? Good to see you out there. Okay, I'm just gonna get the slideshow ready and then we can begin. All right. um, so first of all, welcome to math class. Today we will learn real world problems with composite solids. You might not know what composite solids are yet, but you will learn. Okay. Now, if you look inside of your textbook at the end of chapter 8 on page 169, you're going to see this summary of these basic solids, the volume and surface area of those basic solids over there. Okay, so put a bookmark there, a post-it there, so you can refer back to it as you work on the problems. Okay, all right, so there it is for that. So we're going to do a 5-minute warm-up. Over there, that is something that you can see in real life. Kind of looks like a silo to me. I sometimes see that structure on farms, and they're quite large. Now, what solids make up this particular storage unit? What solids, basic solids, do you see in that storage unit? Well, I see a hemisphere at the top. A hemisphere is half of a sphere. Um, or, and I also see, a cylinder at the bottom. Is that what you see too? We're going to find the volume of each solid. So that means we're going to find the volume of a cylinder and then also the volume of a hemisphere. Okay, so just to recall, the volume of a cylinder is pi r squared times h, where r is the radius and h is the height. And we can clearly see that in the picture over there. And volume of a hemisphere, well, a hemisphere is half of a sphere. And behind my screen, my video box, is the word sphere, okay? So volume of a hemisphere is equal to half, 1/2, right, times the volume of a sphere, okay? And if we input in the values, we can figure out the volume of each of the basic solids. So why don't you pause the video, try to do it yourself in a couple of minutes, and then start the video again to see if what you got matches what I got. So pause it and I'll see you soon. Alrighty, welcome back. So for the volume of a cylinder, I kept my answer with pi in it. I got 200 pi cubic meters. And then for the volume of the hemisphere, I got 250 thirds pi. And then behind my little video screen says cubic meters as well. How come I wrote cubic meters instead of square meters? Well, I wrote cubic meters because we're talking about volume. When we are talking about area, we'll use square meters or square inches or square centimeters, whatever the units are. Okay. Now, this storage unit is called a composite solid because it is made up of 2 or more basic solids. Now, how do we find the volume or surface area of a composite solid? Well, we're going to add or subtract the volumes or surface area of the basic solids represented in the composite solid. Sometimes we might have to subtract, and we'll see in the examples that come later on in this lesson why that would be so. All right, so what I would like for you to do is to read the guided practice and do the guided practice on your own, okay? Um, and I want you to pause the video and try it on your own, and then we're gonna talk about it when you come back to the video, okay? All right, so see you soon. Use page 169 as a guide to help you recall the equations to find the volume and surface area of the basic shapes. All right. Well, welcome back. Okay, so as you can see in the picture, right now, we're going to find the volume of the composite solid to the nearest cubic centimeter. That's part A. So I just made a 3D. I tried to make a similar 3D shape of a composite solid with a toilet paper roll and cardboard or cardstock. And so I see that the volume, okay, is whatever space is taken up inside of the cylinder in, and also whatever space is taken up inside of this cone, right? Okay, so that is the volume of this composite solid. So first I took I was trying to find the volume of the cylinder itself, and to find it I have to do pi r squared times h, and so I put it in r as 12 and h as 15 because that's what it shows us in the picture, and that becomes 2,160 pi cubic centimeters. Now the last sentence of the problem, it says to use 3.14 as an approximation for pi. But for now, I'm going to keep pi there, okay? Because I don't want to deal with pi until my final step. That'll give us a more accurate calculation of the actual volume of this composite solid, okay? So I'm gonna save the pi. All right, so then I found the volume of my cylinder. So now I wanna find the volume of my cone. And so to find the volume of the cone, I have to do 1/3 times pi times r squared times h, and then I inputted in 12 for r. But for the height of the cone, in the diagram, it doesn't tell us the height. I know the slant height, but it doesn't tell us the height. Remember, the height of a cone has to be a perpendicular line that goes from the center of the base of the cone to the tip of the cone, okay? And so to find it though, I can use the information that's given in the diagram. And so I see that the height of this whole structure from here all the way to here is actually 37 centimeters. And then the height of my cylinder is 15 centimeters. So I know the total height and I know part of the height. That can give me this other part here. So I'm going to do 37, take away 15, which will have this as my height of my cone, okay? And that becomes 22. 37 minus 15 becomes 22. And then when I calculate all just the number values, it is 1,056 pi cubic centimeters, okay? But am I done? I am not done because the question says in part A, or the directions say to find the volume of the composite solid. So that means I have to find the volume of this entire structure. And so what do I need to do? Add or subtract? I gotta add, right? I gotta add the volume of the cylinder plus the volume of the cone at the top. So that becomes 2,160 pi plus 1,056 pi. Now here, of course, at this point, what I could do is I can, do 2,160 times 3.14 plus 1,056 times 3.14. I could do that. But you know what I noticed that I like to do because, it just looks cleaner, okay? I noticed that this term here and this term here, they have a common factor. What's the common factor? They have the common factor of pi, okay? So this will become pi times, and then I gotta look at the first term. I'm gonna divide that by pi, and then I'll get 2,160, and then look at the second term. I'm gonna divide that by pi, and then that's 1,056, right? Okay, like this, right? And then so now I have pi times whatever is inside the parentheses. Do you see that? Yeah, okay. And then so when I have this pi multiplied by something else in the parentheses, okay, it's equal to, if I switch the order, okay, so I can just do 2,160 plus 1,056 times pi, right? It's the same thing, okay? So what I'm doing is I just factored out pi, okay? And then, this is equivalent to this because if I end up distributing this pi in the second line here, like times the first term in there, times the second term in there, I will get this line at the top. Do you see that? Okay. And then that'll become, so I just added whatever the numbers inside the parentheses. That'll become 3,216 pi. Okay. Now this is where I can multiply by 3.14. Okay. And then that'll become 10,098 cubic centimeters because we're talking about volume is in cubic centimeters. Okay. Well, now let's look at part B. It says to find the surface area of the composite solid to the nearest square centimeter. Okay, so this is your figure. Okay, it's your 3D solid, right? Okay, and you have to find the surface area of the solid. Okay, so look at where my marker will go around. It's going to go around this cone. And then it's also going to go around the cylinder like this, right? And then it's also going to go around the base here underneath the cylinder. Okay, so that's the surface area. Wherever my marker just went around and touched, that's the surface area of this composite solid, all right? So let's see the first step. Well, the actual equation to find the surface area of a cone is this, that's listed on page 169 in your textbook, right? For the cylinder, it's the surface area of cylinder is 2 pi RH plus 2 pi R squared, okay? And so what it did was it just accounted for this cylinder, right? The 2 pi R times H accounts for this curved surface area of the cylinder. And then the 2 times pi R squared is the surface area of the two bases here, of the two circular bases, okay? But the thing is, though, the actual structure of the surface area does not account for one of the circular bases here. It does not account for this. No. How do I draw an X? No, it doesn't account for that, okay? Right? Because my marker didn't go around two bases. It only went around this base at the bottom. It didn't account for the base there, right? So that's why to find the surface area of the cylinder part of this composite solid, I'm going to take out the 2, okay? The 2 will become a 1 because it's only one base, but 1 times, a value is just that value itself, right? Okay. And then so now I'm going to input in the numbers according to the diagram, and that's what I get for the second line. Do you see that? Okay. And then I simplified to this, okay? And then just like what I did here, Okay, when I took out the pi, I'm going to do the same thing. And then that'll become 504 pi square centimeters. And I'm using square centimeters because we're talking about area, not volume. Okay, so now that's the actual surface area of this cylinder part in this composite solid. Now we have to find the surface area of the cone. Okay, now this is the equation that's given inside your book to find the surface area of an actual cone. Okay, of this actual cone here and here. But in our composite solid, does the surface area of the base count in the cone? No, it doesn't, right? Because the whole structure, again, the surface area is this curved part of the cone, and then it's also the um, curved surface area of the cylinder, and then just this one base at the bottom of the cylinder, and that's it, right? So for the cone, it doesn't account for the base, right? And in the equation, do you see which one is the base? The base is this circle part, right? And so the pi r squared accounts for the base here, okay? And the pi rl accounts for the lateral surface area around the cone here, okay? So we're gonna not count the surface area of the base here, okay? So that's why I put in x. And then I inputted in the numbers for the r and the l, and then that becomes 300 pi square centimeters. And then so the surface area of the composite structure of the composite solid is the cylinder, surface area of the cylinder plus the surface area of the cone, which is 504 pi plus 300 pi. And again, I did this similar thing where I factored out pi, okay? And then that'll eventually become 804 pi. And that, at this final step, I'm going to let pi be approximately 3.14. And then the answer is when we round it to the nearest centimeter, right? It doesn't say round it to the nearest tenth or the hundredth. It says round it to the nearest centimeter. So that's a whole number. It becomes 2,525 square centimeters. Okay? All right. Good job. Okay? All right. Now we're going to complete guided practice number 2. So I want you to examine the picture, read the information that's given in number 2, okay? And we're going to find the exterior surface area of the birdhouse, all right? So now if you look at the bottom of the birdhouse, it's actually a cube. And then there is a hole on one of the sides, right? And then on top of the cube, we have a square pyramid, right? The square pyramid, do you see that? And then I put 13 inches because it was really hard to see in the book, okay? So it's right there for you, okay? To kind of use and figure out. And if you can't see it clearly, refer back to your book to help you. This is on page 165, okay? And it's the guided practice. So pause the video, give it a try, try to figure it out, okay? Surface area only accounts for, remember, okay, just the outside part of the whole composite solid, okay? All right, so I'll see you soon, and when you're ready, press play again. All right, welcome back. How was it? Okay, so now the original surface area of a pyramid is the base plus 1/2 times the perimeter times the slant height, okay? And the slant height in this case is 13 inches. But the thing is, when I look at that pyramid, okay, it's just kind of like, the cone, right? Does the base count as a surface area in that birdhouse? The base doesn't count, right? It's not included in the surface area. of that birdhouse. Okay, so that's why I put a orange X on the B for the base. And then, so 1/2 times the perimeter. The perimeter is 4 plus 4 plus 4 plus 4, right? The perimeter of the base, okay? And so I just did, I'm sorry, it's not 4 plus 4 plus 4 plus 4. What am I talking about? It's each side of the base is 10, okay? So it's 10 plus 10 plus 10 plus 10, or you can do 4 times 10. And then the slant height is 13. And then that'll eventually work out to be 260 square inches. All right. Now the original equation to find the formula for a cube is the surface area of a cube is this. Okay? 6 times E, which stands for the edge of the cube, squared. Because how many faces does a cube have? It has 6 faces, right? And the surface area is the edge times the edge, right? So 6 times the edge is the surface area of a cube. But guys, look at the top face of the cube, okay? Is it counted? It's not counted, right? Okay, because it's not counted, there's only 5 faces of the cube that's counted, okay? So that's why for the cube, I wrote 5 times E squared instead of 6 times E squared. Now, how come I subtracted a pi r squared? Well, the pi r squared represents the circular hole in one of the faces, okay? So that's why I subtracted that. Okay, because the area of a circle is pi r squared, okay? So then when I input in the values, I know the edge is 10, and then to find the radius, even though we're not given the radius, we're given the diameter, and to find the radius is only half of the diameter, so that's why I did 4 divided by 2 for the radius. And then that'll eventually work out to this, which will eventually work out to this. And then the surface area of the whole composite figure is 260 plus 500 minus 4 pi. And because the operations are only addition and subtraction according to PEMDAS, I go left to right, okay, to solve it. And then so that becomes 760 minus 4 pi. And now at this point, I'm going to input in 3.14 as an approximation for pi. And that'll come out to be 747.44 square inches. All right. So that's all for today. And I hope you have a wonderful spring break. All right. I'll see you on Moodle on Thursday. All right. Bye.